So it says an audio CD. Do you know what a CD is?
No, I've
Spins
never heard of it actually.
spins at a rate of 200 rotations per minute. If the radius of a CD is 6 centimeters, how far does a point on the outer edge travel during the playing of a 57-minute CD? So there's a lot here, and there are formulas. Like there is like a direct formula here, but let's do it more intuitively. Okay.
Hmm.
So if you go around a circle, that is the circumference.
Yeah.
And what is the circumference?
The circumference is 12
Oh, I apologize.
centimeters.
My screen, it says I'm still loading. I've already
Oh, it's
started
all
working.
good.
That's
I
from.
see it all right now.
Oh, you do? Oh,
Yeah.
oh, good. I don't know why it's doing it. Okay. Yeah, it's 2 pi r. 2 pi r.
Uh-huh.
And do we know the radius?
6
6.
centimeters.
So if you go around the edge, it's 12 pi centimeters. Like if you could walk all the way around or go all the way around, it's 12 pi centimeters. Is that part okay?
Yeah.
Okay. Now, how far does it rotate in 1 minute? How many rotations in 1 minute?
Let's see. 200.
200. So in 1 minute, and this is kind of how you want to work through these problems. In 1 minute, it's 200 rotations. And how far is a rotation?
Um, 12 centimeters.
12 pi centimeters. Yeah. So every rotation is 12 pi. So you're going once, that's 12 pi. Twice, that's 24 pi, 36 pi, 48 pi, and so on. Okay. So so in 1 minute, it goes around 200 times 12 pi, 2400 pi centimeters.
Mhm.
Is that okay so far?
So I'm multiplying 12 times 200.
Yes, 12 pi.
12 pi. And
Yes.
that's just because I know it's rotating 200 times and it's traveling 12 centimeters.
Each time it rotates. 12 pi centimeters each time it rotates.
Okay. All right, I got that part now.
So in 1 minute, this is how far it's gone. 2400 pi centimeters. But the CD plays for how long?
Um, the CD plays for 57 minutes.
Yes. So you have to take that answer and multiply it by
57.
57.
And then that would give you something that you'd want to use a calculator for. Here, I'll bring it
Yeah,
up, I guess.
absolutely. Yeah, I've got one here too. So there is the sort of exact answer, which is 136,800 pi centimeters.
All right. 1,300. Okay. So then that's the total distance it's traveling for
Yeah, that
57
that
minutes.
that's like if you could put something on the edge and do this whole process, it would go that, and you were to figure out how far did it go. It's this huge number here.
Mhm. Okay. All right. And then,
Like the better example here is your car and your tire on your car.
yeah.
Okay, like if you've ever picked up something on your tire, or like something on there, like some road debris, it goes around, one rotation. Well, how far is one rotation or one revolution? Well, it's 2 pi r.
Mhm.
And your tires have an r value on there. It's encoded in the, you'll see it'll be like a 225, 60,
Yeah.
17. So that last one is either the radius or the diameter, probably the radius. Okay. But that's what's going on here. It's you go round and round and round and round and round, and you do this for a while.
Okay.
Okay.
Yeah. So then just spin it and then
Yeah.
I guess that's currently the radius, right?
Probably. It's probably the radius.
Or yeah, it's like close as you can get it without like a perfect circle.
Yeah. So we can go to two, or we can spend more time talking about number one. What would you like us to do?
Um,
And maybe 3 is more closely aligned to 1 in some ways.
Yeah, honestly, I guess the only thing really I would like to work on 2 and 3. Maybe what's like
Okay.
a easy formula setup you could use for 1? Just
For
like that
1,
yeah, that you could like use on other problems where it's just like bang, 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 order, 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 like just makes it easy for the
yeah, I mean, it's okay. So it's for number 1. For number 1, it's 2 pi r.
2 pi
ti-
r.
So that's the circumference times the number of revolutions per minute
Mhm.
times the number of minutes.
So 2 times, so like the radius times 2 times 3.14
Yes.
times the number of rotations per,
Rotations, revolutions per minute. Yep.
and then number of, sorry, what's that last word?
Number of minutes or time. So
Number of
like if
minutes.
it's
Okay.
revolutions per minute or revolutions per hour, number of hours, they have to match up.
Okay, so then I'd get like the answer for the first one, and that was let's see. It was like, where did it go? It was a huge number, I think.
Yes. 136,800 pi.
Very big number.
Yes.
And then I would be multiplying that into um the radius, correct?
No. This is your answer. I mean, this is your shortcut for number 1. And
Uh-huh.
that's what we're,
Oh, that's just different steps to show everything.
yes.
Okay, so I'm not actually yeah, of course. Yeah, I was thinking I'd actually have to multiply them together.
Okay. Okay. So you ready to go on to number 2?
Yeah, I think so. Number 2, I don't know why, but I struggled with number 2 for some reason.
Yeah, I mean, these are all odd. They're all, we don't, because you don't think of things in terms of rotations. You think of them in terms of straight lines.
Uh,
That's why they're so difficult. Okay, so here's the picture. The picture is really important here. So there's kind of this starting point here. And if you've ever done this, if you've ever rotated a crank, the box will go up.
uh-huh.
Like this line starts getting wrapped around this.
Yeah, it's almost like a pulley almost.
Yes, and it's not to scale, but because it's 10 feet and 7.5 inches, but it is a drawing here. So what we
I
really
didn't even
care,
think about that.
yeah, well, that does help sometimes in these
It's
problems.
almost worth
So
like a picture.
yeah, well, what you'll learn is that you want to crank with a bigger radius for this
Yeah.
problem, but that's not part of the problem. So we want to know what one rotation is. You generally in all these problems want to know, well, what is one rotation? Well, it's 2 pi r.
2 pi r.
Yes. Now you have to make a choice here. We have to decide if we're going to work the problem in inches or in feet. It doesn't matter. They're both right. Do you have a preference?
Um, honestly, let's just say inches,
Okay, good
just because
choice.
10 times 12 is 120.
That's right. Okay, so one rotation is 15 pi inches.
Mm-hmm.
So if we just make a quick table, okay, here's your table, rotations and then distance. Okay,
Rotations.
one rotation is 15 pi inches.
Mm-hmm.
A second rotation is 30 pi inches.
And then a
3
third
rotations is 45
45.
pinches. Okay. Now, at some point, we hit 120 inches.
And that would be like I don't know,
Like, like,
9.
like, well, 15 pi is about 45 inches. 30 pi is about, 100 inches.
Uh-huh.
So we're pretty close. It's actually between 2 and 3 rotations.
In between. Yeah.
Okay.
So
But do you understand what's happening? Like each rotation, this box is moving up a little bit, then it moves up a little
yeah.
bit more. moves up a little bit more. Okay. And so the question being asked is, well, how many rotations is it? Well, we know that one rotation is 15 pi inches.
One
Okay.
rotation is 15 pi
Yeah.
inches.
Okay. And we want to know, well, how many rotations is it going to take to get 120 inches? Well, 120 inches divided by 15 pi inches is the number of rotations.
Hmm. So you're looking at it as, so you know that the 15 and the 120. So you have to move it a total of 120 inches. You know, every
Yes.
single rotation gets rid of 15 of them. So
15
then
pi, 15 pi.
15 pi.
Yeah.
And then that. So when I have it as 15 pi, am I thinking 15 inches or am I thinking like 45.7 inches?
45.7 inches.
Okay. And I don't know if it's actually 45.7, but that was just my
Yeah.
guess.
Yes.
Around 45. So then 45 inches is like it's like 3.7
Well, so you
meters.
go to your calculator. I mean, you go to your calculator and why don't you calculate 15 times pi? Start
All
with
right.
that. I can tell you're really uncomfortable with the designation with pi. It's 47.124 inches.
Okay, yeah, that's what I got as well. 47.
So every rotation you're going up 47.124 inches.
Hmm. And then if you do it twice, then that's like
94 inch.
95,
Yeah,
94
95. Yeah,
inches. And then you'd have to do one more rotation to get the 120, but it wouldn't have to be a full rotation.
that's right. It's said really well.
Okay. All right.
So yeah, you got to get your calculator. 120 divided by 15 pi, or 120 divided by 47.124.
All right. Clear 120 divided by 47.124 because I don't know if my phone has the pi option or not. And I got, okay, I must have done that wrong because it says like 2.5.
Yeah, that's right. It's between 2 and 3 revolutions.
Wait a second. Oh, no, that is definitely correct. Yeah, if you multiply it twice.
Yes.
Okay. Yeah, never mind. Need to
So
use
it,
my.
so in a really practical sense, if you had two things that you could turn to pull the same object,
Uh-huh.
you would you would want to turn the larger one. Whatever mass you have here, you don't have to rotate it as much if you have a big
Mhm.
pulley or a big
Yeah, like
wheel.
you can roll it like, 1/4 and then boom.
Yes.
And the other one you
Yes.
gotta roll it like 3 times.
Yes. Yes.
All
Okay.
right. It's like some abstract face almost.
Right. Now, so yeah, it is. And so it's so that what's kind of another interesting thing here is like, let's just say you can't turn this by yourself. But
Uh-huh.
if you get three, yourself and someone else, and you all start turning pulleys that are tangential to this or wheels that are tangential to this, actually
Hmm.
that one's going the wrong way. Um, well, yeah,
It
actually
works. It
it worked.
works.
Yeah, you realizing like, oh, if all three of us pull or push these things, we can push the big one, and that's better than us pushing a little one.
Yeah.
And this is stuff you'll see in physics, things like that.
Uh,
Okay, ready to go to the third one?
yeah, I think so.
Okay. So probably for you, it's good to, whenever you see a pi, to immediately multiply and get a number that's a reasonable.
Yeah, that's always my first step with it. Or my first step's always like just figuring out the radius diameter kind of
Yes.
stuff. And then I multiply that by pi.
Yeah. All right. So Melanie rides the merry-go-round on her favorite horse and sits on the outer edge. So uh, it's a circle again. It's 8 meters from the center. Her sister Melody sits in the inner ring, which is, I'm drawing a separate circle, 3 meters from the center. Okay. And they
Yeah.
say in 10 minutes, they go around 30 times. Okay.
Hmm.
Great. What is the average speed of each sister? Okay. So
So
we'll get to the, What's
I
that?
have one question just before we
Yep.
go into
Yep.
this with the average speed. So I don't know why, but like I just wasn't really getting the average speed thing because I don't know, my teacher just couldn't really explain it that well to me, in my opinion. But there was like, so with the average speed, I'm like figuring out like how am I actually figuring out how quickly they're moving, or is that like in a matter of acceleration?
So the no no let me so this there's a simple formula. Distance is rate times time. Their
Uh-huh.
speed, their rate is the distance traveled over the time.
So the rate is the distance over
Yes.
time. So
Yes. So when you're
I
in your
have
car, when you're in your car driving down the road, with your friends, if you go 10 miles in 10 minutes, that's a rate, or that's a rate. Distance over time.
uh-huh.
Okay. So
That's
this is rate is really speed. Rate is really speed. It's the distance you go over the time it takes you.
distance over time rate. Okay.
Okay, now I'm gonna ask you a follow-up question to that. Do you have something you want to ask about this? Because there's before we get into the actual problem, there's something intuitively that's very important about this.
Um, will they have the same speed?
That they will not. So here's why.
And then, all right, yeah, I guess I was gonna ask that.
Yeah. So let's just say there's a pole right here. Okay. And you are really close to the pole. Okay.
Uh-huh.
You go around, you make a circle around this pole. Okay. And here I am a little bit further away. Since I have to cover more ground, do you agree I have to cover more ground?
Yeah.
I have to be going a lot faster.
Hmm.
So if you've ever tried to do this, all right, hey, I'm two people standing here, we're gonna do a race. Why do you know now why you want to be in the inner lane?
You got like less distance to travel.
Exactly. Exactly. So you see this in the races all the time. Um, if you try to do this, like if you try to just stay like in contact, so, like when this person's here, you're up here, you have to run so much faster to get there.
Yeah.
Okay. So the idea on a macro level, you're not a flat earther, are you? You believe the earth is
Uh,
round?
I do, unfortunately.
Okay, okay. So here's the sun, and what we got here? We got Mercury, right? Venus, Earth, right?
Hmm.
So we're moving way faster than Mercury or Venus.
Yeah.
Okay. Um, and then there's planets out here. They're going even faster than we are to rotate the sun in the same amount of time,
Hmm.
right? But they don't. That's why some move slower. There's other things that factor. But the idea is that we don't realize this, but if we were always to be in aligned, these planets out here had to be moving super, super fast to get
Yeah.
there, but they don't. I mean, they move a little slower.
Yeah.
So the
They
better
do.
example is like trying to keep up with someone. So to answer your question, no, uh, they're not going the same speed. Like the one on the outside is going a lot faster.
Uh-huh. But they are covering the same distance in the same amount of time.
They are not. The one on the one that's closer in is not
Right.
covering.
Actually, they are not. They are making a full rotation in the same amount of time.
Yes.
Okay.
Yes. So we have to figure out the what one rotation is for each person. One rotation for the one that's on the further out is 2 pi r,
Uh-huh.
8, and one rotation for the other one is 2 pi 3. So
And
16
then
pi, and I would just go to your calculator and figure that out, what that is. 16 pi and 6 pi.
um all right.
Let's get numbers for those, please.
Um all right. Is there an actual pi button on the like iPhone calculator?
Yes, you have to rotate your screen, and you should be able to get it.
Wow. All right. I did not know there was all
Yeah,
that. Pretty
yeah.
interesting.
I recommend downloading the Desmos Scientific app. I think it's a little bit stronger
Uh-huh.
than that calculator on there.
All right, cool. I'll make
But
sure to do that.
what do you got for
Sorry, I'm just trying to find the actual pi symbol. Um,
I think it's there. I don't use it very
there it
often.
is. All right, it was like in the small part times 3. Um, like 16.3.
For which one?
For the no, that's not it. Sorry, I don't know
Yeah.
why. Like, here at 1 second, I just gotta check this.
It's always okay just to do 3.14.
All right, maybe like 50 point
Let's be able yeah, give me the
4.
full, yeah, the full.
50.2654 for the 16 pi,
Okay, yeah, 50.265. And then how about for 6 pi?
and then 6 times 6 times 3.14, 18.85.
Right,
18.85.
right. Okay, so notice that the one on the outside covers more ground than the
Uh,
one on the inside.
yeah.
Okay, and that's important. That's important. So the distance traveled, because the formula is distance over time. Well, the distance traveled is going to be more on the outside than on the inside.
All right.
Is that
Yeah.
okay?
Mhm.
Okay, so they go around how many times?
They're going around 30 times.
30 times. So you have to multiply both of these numbers by 30.
Man, it's gonna be some big numbers.
Yeah, 50.265 times 30
I'll
and
just start
18,
calculating those.
yeah, times 30. And that's your distance. That's your distance traveled.
All right, 1,507.
Okay,
Oh, wait, they already went 50,000.
50.265 times 30 should be about 1,500-ish, plus a little bit.
50.265. 1,507.95.
Okay,
So
okay,
like, would I,
but go ahead.
sorry, one question. Would I just round it up to 1,508 or just keep it at the 7?
I don't recommend rounding until the end, which is kind of one of the reasons I don't like using the phone, because it doesn't allow you to keep the numbers as you go. Um, that Desmos scientific will be a little better because you can hold stuff in there. Because you really need to divide both of these by how much time.
Oh,
How much time were they on the merry-go-round?
yeah.
10 minutes.
Oh, right. Sorry. Yeah,
So
10 minutes.
you divide both these by 10.
And then, so you're gonna multiply it first and then divide it by 10, correct?
Sure. Or you can say, oh, 30 divided by 10 is 3. So it's 50.265 times 3.
Yeah, that's
That's
actually
fine.
smart
That's
as
fine
well.
as well. But you're going to see that the person on the outside is going faster. So if you want the
Uh-huh.
bigger thrill, you sit on the outside of the merry-go-round. Although it's never going fast enough, I think, for that to happen.
Yeah. Huh. All right, interesting. It's like, I guess first time I've seen a word problem where I actually like, oh, makes sense.
Yes. Yeah.
So then I guess once you multiply those all together and divide it, um, you would have the speed
Yes.
of the person.
Yes. So the one on the outside is going about 150 meters per minute, and the one on the inside is going about 55, 6 meters per minute.
Oh, and that's
And
just speed. They're just cruising
yes.
along.
Yes. Okay. And these aren't correct SI units. Like you would do meters per second or kilometers per hour. These are weird. You wouldn't say meters per minute, but
Yeah.
it's the whole point of this problem is to see that you go faster on the outside than on the inside.
Yeah. And I do see that. So looks like it worked out.
Yeah. All right, so got through those. You've got a number of problems here with circumference and diameter and radius, and I think these might be good because there's but that asks for both the exact and the approximate answer, which I think could be frustrating for you. Or we can go to like number 11 and 12 word problems, 10, 11, 12, any of those.
Um, yeah, I'm might as well just finish off the word problems and then just go over the more simple ones.
Okay, let's do number 10 first. This is kind of just a not really like it more like the 1 through 9, but let's take a look here. What's the circumference of a bicycle wheel with a 27-inch diameter?
Um,
Circumference is 2 pi r or pi times diameter. Both are valid.
um, that would be so okay, wait, sorry, I just need to read that again. So the circumference, the total circle of the bicycle wheel. So there's a 27-inch diameter that just the circumference is 27 as well.
No, the circumference is 2 times pi times r. They're telling you the diameter in this problem is 27 inches.
Is the diameter the one that goes halfway across?
No, the diameter goes all the way across.
Okay.
A
Um,
radius is just halfway.
okay, that's what I thought. I was just a little confused. So I mean, I guess it would have to be so 2 times pi times r. So then um
So there's two ways to do this. You either use the formula on the right, pi times diameter, 27 pi,
uh
okay, or you have to find the radius. So the radius is the diameter cut in half.
yeah,
So the radius would be 27 divided by 2, which is
like 13.5.
13. So if you put that in the formula, it's 2 times pi times 13.5. It's still 27 pi.
Uh
And
so
they're the
I
same.
guess
And they're supposed to
same.
be. They're supposed to be. Both
So
formulas are valid.
and then I multiply it by pi?
No. I mean,
Oh, so that's like
this
that's
is the
it.
exact answer. This is exact.
Like I'm literally just writing 27 pi
Plus the units.
and the units.
Yes,
Okay,
this is
that's
exact.
so okay, wait, yeah, sorry, that's I don't know how I didn't get that. That's silly. The like yeah, the diameter, like that's what the circumference is. It's like, just the diameter.
Times pi.
Yeah, times pi. So then okay. All right, yeah, I don't know how I didn't get that one.
Well, I mean, I still sense this like you don't like this symbol.
Yeah, I don't know. I just don't like the because like sometimes you multiply it by like 3.14 and then sometimes you don't. Like I don't really know like
So now
the
the
difference there.
approximation is when you multiply by the 3.14.
Uh approximation. So then
Okay, so 27 times pi is 84.823 inches.
84.823 inches. And then that's your approximate, the exact's 27.
Yes.
And then what even is like I understand like exact because it's like literally there. I don't get what's the whole deal with this like approximate? Like is it like the total amount of like space inside it or something? Or
Well, if it's like if you want to know how far you walked around something, we like it in we like it in like inches or meters or feet. Like that's I just want to know how far you went. Don't tell me it's 27 pi feet.
uh
It's because I was like, oh, how far, you went for a walk, how far did you go? You're like, oh, I went 27 pi. Like that doesn't mean anything to me.
yeah.
It's kind of like when we were talking about square roots. I'm like, oh, I had square root of 5 pounds of um hamburgers this weekend.
Yeah, you just can't
Does that
do
mean
that.
anything to you? Or if I tell you I had 2.3 hamburgers, is that a little more?
Yeah, then it's like, oh yeah, makes sense. It's like, yeah, two.
So the exact though is really important when you're solving complex problems. Um, but in terms of like usefulness, it's better to talk about the approximate.
Uh-huh. Okay, that makes more sense now. So should I always show the approximate as well?
Yes, because it even says here in the other side, it says find the exact and approximate for the requested values.
Okay. All right. Yeah, I'll make sure to do that.
And it's easy to overlook that, but the more comfortable you get with this pi thing, you're gonna just it'll be natural. You'll just say, oh yeah, it's just pi. Pi is a number. It really is. It's misunderstood,
Yeah.
but it's a number.
All right. Yeah, not yeah, I guess it's always going to be the same number no matter what. So,
I think I wrote a blog post on this last for Thanksgiving because of all the circles and pi.
uh-huh.
Um,
Oh yeah, good time for it.
yeah, I don't know if that's I don't know if there's anything in here, but um, so uh, yeah, here you go. The irrational number pi is one of the most misunderstood numbers because you prefer to see whole numbers, fractions, and decimals, which are friendly. Okay. The
Uh-huh.
reality, though, is that there's just as many unfriendly numbers as there are friendly numbers. Like for every 1, 2, 3, and 4, there's 1 pi, 2 pi, 3 pi, and 4 pi. Like there's just as many. Like we like to think, oh, there's more of these nice numbers than not nice numbers. There's actually
Yeah.
the exact same number. So they're, they're
Nothing
out
nice.
there. Yeah.
Yeah.
All right. So here we go. Ferris wheel. Ferris wheel. All right. If the distance from the center of a Ferris wheel to one of the seats is approximately 90 feet, that's the radius. Okay. That's the radius. What is the distance traveled by a seated person to the nearest foot in one revolution?
Oh.
One revolution is the circumference.
And then that would just be 180, correct?
That's 180 pi.
180 pi.
2 times pi times 90.
2 times pi times 90. And then, right, because 90, then 180. So then,
Okay, like let me just back up here. So if you unwrap this circle, do you agree that it becomes a line?
yeah.
Okay. If you have like a can with a label on it, if you were to cut off that label and try to measure its length, I can almost guarantee you it's not a nice number.
Uh-huh.
And it's because of the pi. It's because the pi is what allows us to have some idea of how to measure this. Because it's never nice when you roll it out straight. Still not making any sense. Okay.
Well, sorry,
Okay.
I was just
That's
listening.
okay. It's okay. So this it's 2 pi times 90. It's 180 pi, but then
Uh-huh.
it's feet. Feet. The pi is not a unit. Pi is a number.
Yeah. So there's like, it's like I understand that like the circumference is 180. I understand that like pi. I also understand that radius is 180. And then I know that like pi is 3.14. And I know that if I like stretch this out, like, I don't know, like the way like people like bend up railroads in a sense, like to ship them, and then like the actual like rails themselves, and then they like straighten it out to like lie it out in a sense. Like I
Mhm.
understand it's like kind of the same, where it's like there's like a total distance. It's not just like you're going up and down,
Right.
but it's like So am I just gonna multiply like 180 times pi
Yes.
in order
Yes.
to figure out that distance?
Yes.
And then I guess that would be like 180 times 3.14. I can type that out. 180. Whoop, 180 times. Oops. 180 times 3.14. 565.2.
There's foot. So single ones digit.
Oh, okay. 565.
Yeah,
Total. Um, so that's like how much that's how many feet you go in a rotation.
that's right.
Right? Is that kind of all it's asking for?
That's it.
Okay.
Okay,
Yeah,
so
I don't know.
I just
Something
want
with
to I want to try to give you more on pi. So pi is the ratio between the circumference and the diameter. Okay,
uh,
this is always true. Okay, it doesn't matter. What's the smallest circle maybe you can think of?
um how about a hole in a Cheerio?
What? So give it one more time.
A hole in a Cheerio.
Hole in a Cheerio. Okay, yeah. So we can measure the distance across. That's the diameter. We could also somehow find a way to measure the distance around. Like if we used a little piece of string and we laid it out like this, we can measure it.
Uh-huh. Like
Okay.
we could wrap around it.
Right. Yes. Okay. Now something a little bigger like a quarter. Okay. Same thing. We can measure the diameter across. We could use a little piece of string, go all the way around, lay it out like that. Okay. And then you could choose something bigger, like a dining room plate.
Hmm.
Every time you do this, and this is what's so amazing, every time you do this, the ratio is always pi.
It's interesting.
Yeah, it doesn't matter. And that's like this was frustrating. This was a frustrating problem to solve. They like this ratio is always the same, but we don't know what to call it. So we call it pi.
Uh-huh.
So this is not the first time in math that you maybe come across something where we don't know what to call it. So we give it a name.
Yeah.
Do you remember what the square root of -1 is?
Um it's is it just is it positive one?
It's I.
Oh,
Maybe you haven't seen that yet.
I'm not sure if I have actually. That's
Okay.
interesting.
So maybe it's the first one, but this is something you actually see in math more times than you would think, where we don't know what to call something. So we come up with a symbol to explain it.
Yeah, to represent it.
So it's like pi is not 3.14. It is the ratio of the circumference to to the diameter.
Hmm.
You want it to be you want its numerical approximation, but that is not pi. Pi is always the ratio of the circumference to the diameter.
Okay. All
And
right.
so sometimes we do that. We do that like like north means up, but why?
Just us.
Somebody said that way's north, and we just go with it, right? We don't
Yeah.
question it. We just go with it. Um, a light's like why is are you taking chemistry?
I am taking physics. Well, actually, no, I am taking chemistry now.
Okay,
I
so
have
why
chemistry.
are electrons negative
Um,
and protons positive? Why aren't they reversed?
just yeah, someone just said they were, right?
Yeah, and we just go with it. And so you have to accept that what pi is not 3.14, is that it's the circumference over the diameter.
Okay.
Are you
All
still
right.
playing? Are you still playing tennis?
I am. I just
Okay, so your tennis ball, even though it's a sphere, if you ever have a dead ball, you can cut it in half if you want, but it is the same thing. The circumference over the diameter is pi every
Uh-huh.
single time. And it's kind of amazing. It's kind of amazing
Uh-huh.
that
Yeah.
works.
How did someone ever figure out that number in specific?
Not any way you would understand at this point.
All
It
right.
involves what's called a Taylor series of a function, and we don't need to get into that, but
Yeah, we can save it
yeah,
for another.
yes. Okay, so I think we got through the word problems, right? Or no,
Yeah.
we've got the 12. Should we do 12 or should we go into some other ones?
Um, do you think we could just briefly go over the other ones? Because like I think I
Yeah,
get them, but
sure.
just want to, double check.
Yep, yep. All right, so number one here. Says if the circumference equals 5 pi, find d. So circumference is pi times diameter, and if the circumference is 5 pi, you can divide both sides by pi, and the diameter is 5 centimeters. Is that okay?
Yeah.
Okay. Number 2, let me make sure 2 is a little bit different. Yeah, it's a little different. So this time they're giving you R. And if you need to, you draw a circle. Circle,
Yeah, that's what I've just
5,
been doing, just double
yeah.
checking.
Circumference is 2 pi R. So it's 2 pi times 5, 10
Just be
pi
10
centimeters.
pi.
But
All
then
right.
but that's the exact. Now, if they want the approximate,
Then yeah, I have to multiply 3.14 times
yes.
10.
Yes. Now you might ask, well, hey, why didn't we do that in the previous problem? It's because this is both the exact and the approximate.
Yeah, that's the only possible answer.
Yes. Yeah, and to your point here, like if I want to know, if you want to explain this to someone, you would say it's 31.4 centimeters because that means something to us.
Uh-huh.
Right. All right, so let's look at number 3. Okay,
Um,
if C equals 24 meters, find R.
um,
Circumference is question.
oh no, go on.
Circumference is 2 pi R, and they're giving you the value of C. They're saying C is 24. 24 equals 2 pi R. To solve for R, you divide by 2 pi on both sides.
And then that would just be 12 pi,
Oh, no, 12 over pi.
12 over pi
But it's got units, so it's really 12 over pi meters.
meters.
And then if you were told to, like you are here, this is the exact. And the approximate, you go to your calculator and you get 3.82 meters.
3.82 meters. Okay. And that's right because it's half of it, so then I'd be dividing it rather than multiplying it in this scenario.
Yes. Yes.
Okay.
Okay, we got time to look at least one more here. So number 4. If the diameter equals 5.5 meters, find C. C is,
C is 5.5.
yeah. Now this is where you might want to use the alternative form, which is pi times diameter,
Uh-huh.
because they gave you the diameter. So it's pi times 5.5 or 5.5 pi meters. That's exact.
And then approximate would be 5.5 times 3.14.
Yes.
And then I can do the calculator real quick for it. 5.5 times 3.14, 17.27
Meters.
meters, right.
So make sure you throw those units in there. All right, let's do number 5, I guess. If a circle has a diameter of 12 centimeters, what is its circumference? They're telling you that the diameter is 12. Circumference is 2 pi R or pi times diameter.
So
Sorry.
then that would also become 12 centimeters.
Pi times 12
Pi times
centimeters
12.
or 12 pi centimeters.
12 pi centimeters. And then to get the approximate, it would have to be 12 times 3.14. Let's see. 12 times,
Should get 37.7 centimeters roughly.
yeah, that's what I got.
All right, I'm going to just stop